Well, welcome everyone. Hopefully everyone can hear me. I'm really excited to invite you all to this thought leader dialogue on designing computing education for everyone that's hosted by Northwestern's Human Computer Interaction and Design Center. So today's conversation is going to touch on a topic that I think is particularly timely. As HCI researchers and designers and practitioners, we know that computers are kind of increasingly mediating our everyday lives. However, broadly, few of us get to participate in designing the systems and the interfaces that we interact with on a daily basis. And this is in part because computing education has kind of historically focused on training a select few to become software developers. But this landscape is changing. So computing is increasingly being viewed as a core literacy that has value for all learners. So today we're bringing together three really fantastic thought leaders to discuss how we can design computing education for everyone. Just a couple of notes on kind of how the structure of this will work. So we're going to have three talks by our fantastic speakers, Dr. Betsy DeSalvo, Dr. Tiffany Barnes, and Dr. Mark Gustile. We'll be collecting questions. So if the audience has any questions that you'd like to share, please feel free to share them through the Q&A box. So we'll have these three talks back to back, and then at the end, we'll have about 20 minutes for a panel discussion. And we will be sharing some relevant links in the chat, so feel free to take a look at that as the speakers are sharing their research. So we will jump right in. I'm really excited to introduce our first speaker, Dr. Betsy DeSalvo. Welcome. Dr. DeSalvo is an associate professor and the interim chair of the School of Interactive Computing at Georgia Tech, where she directs the Culture and Technology Lab. So in her research, she works with a wide range of community organizations and uses participatory methods to better understand and design technology for minoritized groups. Dr. DeSalvo is on the editorial board for Transactions in Computing Education and has held a number of leadership roles in the ACM and educational research associations. She's an expert in responsible computing, learning sciences, participatory design, and human-computer interaction. And so today we're really excited to hear how she applies these different lenses to the challenge of designing computing education for everyone. So Betsy, feel free to take it away.
Great, thank you. Let me just get the right. All right, I believe you can see the right screen now. So I'm going to talk a little bit about expanding acceptance in computing pathways. And this work is coming out of my lab, which is the Culture and Technology Lab. We look often at how culture shapes the production and use of technology, and much of our work has been looking at different sort of user groups or alternative sort of approaches to designing educational technology to make sure that educational technology is designed well for people from underrepresented groups. But in this talk, I really want to talk about the culture of computing, not kind of other cultural groups. And the reason why is because, we often think about who is a computer scientist, who does computing, who is a software engineer or a programmer. And I want to give you one example, which is Laura Schenek. And she is a senior principal, or was a senior principal software engineer. However, Laura is not generally considered a programmer or a computer scientist. And the reason why is because Laura has a bachelor's degree in fine arts, not in computer science. And she started supporting herself as an artist with front-end development work and then eventually became a software engineer. But she doesn't have the cultural background of computing. And throughout her career, she's felt it frequently, how she is sort of not considered part of the computing culture. And she has this wonderful blog where she documents a lot of that if you want to look at it. So why is it that she is not part of the computing culture? And part of this is because domain-specific languages, declarative languages like Excel, HTML, CSS, are not considered programming. And mythology is that real programmers are those who come out of computer science programs and have a certain set of cultural markers for themselves. This means there's an exclusion of people who learn programming through what I would call novice-friendly technologies, often called, more like end-user programmers. right? So why is it that those sort of groups are continually excluded? Many of this is because the computing field actually encourages gatekeeping. One of the best examples of this, I think, is the technical interview, which there's really not a lot of an indication that a technical interview is any more of a way to tell if somebody's very good at computing or if they just know about the technical interview before they start applying for jobs, right? It's not a great marker of who's going to do well as a software developer. It's more of a hazing ritual, really, that you need to have the cultural background to understand. And so this inhibits the career growth of non-traditional learners. So, building upon this idea that computing is lacking in representation, that it can be exclusive, and we need to change how we teach it and how we can be inclusive of other groups, we started to look specifically in the data science sector. And I don't need to tell you that like data science is pretty important these days and how it's shaping our world so much today. And we know that there are a lot of researchers out there who are documenting the inequalities caused by data. And we know that there is a lot of bias baked into much of the data that we use every day based on data collection, what data is cleaned, what data is selected from that, and then finally the analysis. And this is a problem because so many see data as revealing the truth. We see this particularly amongst people who consider themselves scientists, right? That the numbers are the facts and that is therefore the truth. But that really isn't correct because there's very many different interpretations of the data and which data is included as fact or not fact based upon the backgrounds of the people who are doing the data work. So we think that being more inclusive in this particular field is very important. And we also see that the labor in data is kind of unique to computing in some ways because so much of the labor that's involved with data science is actually done with things like Excel or much more novice friendly programs, right? So what is that labor that actually makes data science possible? And how do we support that labor so that it's fair and inclusive to the field of data science, but also so that it is fair and inclusive to the laborers so they have an opportunity to move through this career trajectory? So to answer this question or sort of address it, we have developed a program at Georgia Tech. You know, we've seen many efforts and millions of dollars spent on broadening participation in computing. Most of this is devoted to trying to bring people in from underrepresented groups through K through 12 formal education and informal learning workshops and camps. Some of it has been done at an undergraduate level. And there's been so many people who have taken on this work to try and increase awareness amongst underrepresented groups as well, to get them interested in going into computing. But despite all of these efforts and millions of dollars that is spent on this, we've seen little to no increase in the diversity in the computing field. So in the CAT lab, we really think that a new approach is needed rather than relying on this kind of deficit view of fixing the people who aren't in computing by providing new ed tech or trying change their perspectives about what computing is. With data work, we're seeking to leverage situated learning environments, offering legitimate entry-level work in computing that builds people's interests, skills, and identity in computing in a very authentic manner. The program's called DataWorks, and it seeks to understand how to build this critical data literacy amongst our employees. So DataWork hires young people, well, actually not super young people, but hires adults who are from underrepresented group, typically from low income neighborhoods, and it really operates like a small company out of Georgia Tech. We train these people at different mid-level data skills and employ them as data wranglers and data developers. We offer a range of services to our clients, both inside and outside of Georgia Tech, and we're paid for those services, which helps sustain the program. We also assist with some very entry-level work like data cleaning that's very hands-on, but we also do a lot of automated work, web scraping, and things, and some analysis at different levels and visualization, right? The workers are paid a living wage, they're employed full-time with benefits. These are all very important things because we see a lot of the people doing entry-level data work have no room for growth, but also they're extremely underpaid and they're often really marginalized further by the work that they're doing for data scientists. So our process is that clients may have data needs and they contact DataWorks. We review their data. We often do a data audit, doing some interviews, actually looking at what they currently have. We have some conversations about what they want out of their data. And then we develop a plan of action and share it back with the clients with a quote. As we process the data, our workers are continually not just doing the work itself, but almost every single data project we work on is completely different. So they are constantly learning new skills. This is just a handful of the organizations that we've worked with. We've also done a lot of work internally with Georgia Tech doing data annotation. But I just want to show you one project to give you an idea of the kind of work that we do. Oops. There we go. And this project is with the Carter Center. So the Carter Center has been working on understanding and mapping the explosive munitions in Syria. So what they do is they track basically Twitter feeds that are reporting munition use in Syria. And what we do is take those Twitter feeds, we import them into a database, we sort them, separate them, clean that data because it's often pretty messy. We use a lot of automated methods, but it also takes a lot of hands-on work. And at the end of this, we've been able to produce this sort of very clean data set for the Carter Center, which in turn they've turned into an annual report, which really documents the use of munitions in Syria, which is pretty depressing, I have to tell you, if you look at how many bombings happen in Syria each day. But it also helps them identify where munitions were dropped but didn't explode so that they can go in and do extraction on that. It's extremely powerful work, and our data workers feel great about the work that they're doing, and they're learning a ton of new skills through this. So that's just one example of the work that we do. We also do a lot of research with DataWorks because we are part of Georgia Tech and it is partially funded by NSF. So we seek to understand how individuals from these minoritized communities learn data skills, tools, and processes. But we also do a lot of work on thinking about how we can have employees in a technical sector co-design that workplace, right? And this is done through participatory design methods where we really open up how we basically plan our functions on a day-to-day basis. And I think one nice example is we had a project where the data workers were doing some data annotation on some natural language processing data sets around African American vernacular English. And what they found was the current algorithms for producing this NLP was pretty stereotypical and really difficult for them to read, 500 in a different text that were giving these very stereotypical kind of offensive comments. So they came back to the researchers actually and helped them redesign their study so that it could be done in a more ethical manner, right? And actually, I think that the researchers themselves would say that it produced better data for them. So this is super quick, but what are we learning? Critical data literacy is needed. We're learning that actually our clients don't see their data through a critical lens, and oftentimes our data workers bring that. We see that full membership in a data community of practice is more than just the data scientist. Both our partners in industry and nonprofit are often data scientists who don't go by that name, but also our data workers are pretty much part of that community practice too, without getting the membership kind of label. We see the labor force working in entry-level data is often exploited. And we see full membership in computing through data science means navigating gatekeepers in exclusive culture of computing. So I want to just jump back to Laura, who is now a PhD student working with me at DataWorks. I'm super lucky to have her. But based off of her experience, and working with the data worker, she's developed a curriculum for navigating careers in computing with a non-CS background. So for her, she's really understood that networking is very different. You have to overcome a lot of this disparaging humor that you hear about people who are not real computer scientists or programmers. Look at the hierarchies and understand them within the division of labor and computing. And then finally, really prepare for things like interviews, like those actual formalized gatekeeping that happens in computing. And so that is sort of where we're at right now and kind of what we're working on. And I'm happy to take questions at the end of the all the presentations.
Wonderful. Thank you so much, Betsy, for that really insightful talk. We're looking forward to getting a chance to talk through some questions at the end. But next, we'll move on to our second speaker, which is Dr. Tiffany Barnes. So I'm excited to introduce her. Dr. Barnes is a distinguished professor of computer science at North Carolina State University, where she directs the Games to Learn lab. In her research, she studies the ways that artificial intelligence, data mining, and serious games can enhance education, and she's had a particular focus on computing education. She served on the board of ACM 60, the International Educational Data Mining Society, and the International Society for AI in Education. And she's also co-director of the STARS Computing Corps, which is a consortium of universities that engage college students in outreach, research, and service to broaden participation in computing. So she's an expert in expanding access to computing education at the state and national level. And today we're really excited to hear about some of her new initiatives in this area. So Tiffany, feel free to take it away.
Great, thanks so much. It's really exciting to be on this panel and really exciting to hear what other people are doing. My name is Tiffany Barnes. Thanks for the nice introduction. I'm at North Carolina State University, and I want to talk to you a little bit about STARS. So I really think that it's very important these days that everyone get a chance to get engaged in artificial intelligence and computer science. So I'm going to include artificial intelligence there because it's really a huge focus right now in the sort of public mindset. And I'm going to go back in time a little bit and tell you a little bit about STARS and what it's centered on and how I think maybe we can rethink computing education around some of the principles we use to design STARS. So back in 2006, the National Science Foundation gave a call for bringing in more computer science students and more diverse computer science students. And we wrote a proposal for STARS Computing Corps to answer that challenge. And the real center of that proposal was that faculty alone could not actually dramatically change the number and diversity of students in computer science. And Betsy's totally right. You know, there were many alliances funded under this program and many initiatives started to try to broaden participation in computing. And we still haven't moved the needle. We don't have the diversity that's very important. And we don't have the number of people learning computer science that we really, really need. And it's critically important that more people learn computer science. So I'm going to tell you a little bit about STARS, but mostly it's going to focus on the central idea of it, which is that students are the most important people when we're thinking about making changes. These are the current leaders of our STARS program, and I can't do anything without acknowledging that there are many, many people that are making STARS work. Jamie Payton is our director, and I'm the co-director and co-PI. So the goal of STARS was to shift experiences for students in college computing departments to be more equitable and inclusive, and increase rates of degree attainment and persistence among especially Black students. And the way we do that is by building capacity for broadening participation in computing, get people excited about doing it, and foster a community around the commitment to make things better. And we have been present in many states, mostly in the Southeast, over the many years of STARS. And this is what I wanted to get to. So the STARS Leadership Corps was a central idea of STARS, and that is that students actually are the people who can make a difference. So back in 2006, we designed STARS to focus on bringing computer science education to everyone, students, especially outside of colleges who had no access to computer science education. That has changed a lot now. So what does that mean? What I think that means is that if we really want to think about computer science education right now, we really need to think about the students who are in our programs and the students who are not in our programs. But we could possibly make a big difference if we can take the students who are in computer science programs and help them make things and imagine what the students coming up behind them would like to see and would like to learn. So that's been really central to STARS, and having them imagine, like, what is the need? How can we broaden participation in computing? How can we make computer science education better for others? And it's always been very central to STARS and to basically all of my work, to center student views and student work in this. So now I'm going to go actually off of my slides and talk a little bit more about this. So there are a couple of, let me just take the slides off. There are a couple of things that I'll mention, and I'll put them in some links in the chat in a few minutes. So one of the things is, many of you may or may not know that there are a number of artificial intelligence institutes being funded around the country right now, because the importance of artificial intelligence has increased so much. It's in everything that we use, and in the future, it's only going to get more. So we really need to have conversations about what's going on with AI. How's it getting used? Who gets to make it? Who gets to work with AI? I think right now we don't have very many people being able to use it, except that ChatGPT has come online, right? So now we have people who can sign up for an account with OpenAI and work with ChatGPT and ask questions and get responses. That's a really great technology, but how's it going to be used? Who gets to decide how it's going to be used? If we don't have these conversations right now with the people who do know computer science and who do know enough about AI to do something with it, the people who already do understand AI are going to make all the decisions about how it gets used. So what I'd like to envision is a new future where a lot more students in universities and in other places get a chance to be involved in the conversation about what AI does, how it should be used. And we need to start thinking about how we educate people to work with AI. So many of our systems have been replaced with AI, and what we're going to be doing in the future, I believe, is trying to build collaborative systems where people are solving problems, where AI actually is one of the problem solvers and humans are one of the problem solvers. So one of the really important things I think we need to do is think about, how do we design education for people to learn how to interact not only with computer science, but with artificial intelligence, and to solve important problems, solving problems like climate change and other problems that are facing us right now. In the United States, we've got wildfires in Canada that are affecting the entire United States. And this is only one example of the global impacts of different problems that are going on right now. And people are starting to realize, like, hey, these problems aren't just somewhere else. They're going to be affecting my backyard every day. So I really think we need to envision, what can we do so that every person, students and other people, can get involved in problem solving these really important problems. We need better interfaces like ChatGPT, but they need to be leveraged for problems that people think are important. I really think this is a time where we need to think really hard. How do we design these systems, and how do we make it so that everyone can use them? And I think the work that Betsy and Mark are doing are two of the ways that we can get to being able to build those. But I really think that that's where we need to go. And going back to STARS, faculty can be really instrumental in making a big difference for this by seeing our role as bigger, not just teaching whatever class we have, but also enabling leadership from students and young people. How can we make it so that people can get involved in these larger conversations and make contributions? So that's what I really wanted to do, is just open up the idea there and go back to the idea of AI institutes and the fact that there are huge groups of researchers working together now to envision the future of AI. And I'd like to also sort of propose that we get more and more people involved in talking about this vision. Thanks.
Fantastic. Thank you so much, Tiffany, for that really thoughtful discussion. Lots of questions coming up around that topic. All right, so we'll move on to our final speaker. I'm really excited to introduce Dr. Mark Gusdile. Dr. Gusdile is a professor in computer science and engineering, and also the director of the program in computing for the arts and sciences in the College of Literature, Science, and the Arts at the University of Michigan. In his research, he studies how people learn computing and how we can improve that process, with a particular focus on students who are using programming to learn something other than CS. Dr. Gusdile is an ACM Distinguished Educator, a fellow of the ACM, and a recipient of the 2019 ACM SIGC Outstanding Contributions in Education Award. He's an expert in research on designing computing education for everyone and has been thinking about this topic extensively. So today we're really excited to hear about his kind of new or current perspective on this area. So take it away, Mark.
Thanks, Nell. Hey, everybody. I want to talk to you about when Nell invited me to do this, I was so excited because this is what I spend all my time doing now. I am building a new program at the University of Michigan, the program in computing for the arts and sciences. So what we're doing is building a brand new computing education program for liberal arts and sciences students, completely separate from computer science and engineering, completely separate from the School of Information. So I was really struck by Betsy's comments about authenticity. One of the things that we're exploring is what is authentic for liberal arts and sciences students who don't ever want to go into computer science, who may not want to go into data science. What works for them? So I've got three pieces that I think might be useful to people in the audiences. Our process of self-study. How did we answer this question about what do liberal arts and sciences students need? How we've been designing our courses. Betsy taught me participatory design, and I'm trying to follow that method in creating our courses for liberal arts and sciences students. And how we're building this scaffolded series of computing activities to think about students who don't ever want to learn Python, who don't ever really want to, never saw themselves as programmers or even don't even like mathematics and science all that much. How do we help them come into computing? So in 2020, I got asked with Gus Everard, a physicist, to chair a task force that asked these questions. What do liberal arts and science students need to know about computing? What currently exists? I just got here at the University of Michigan in 2018, and I've been struck by how big this place is. It's absolutely huge. And so we had to do a lot of work just to figure out what was already going on in computing education. So I've done dozens of interviews. Gus has reviewed hundreds of courses. We surveyed over 100 faculty. Our final report is available at this QR code. We had a great task force of folks from across campus who worked on this with us. One of the things that emerged from this process was that in liberal arts and sciences, there are really three themes for computing education, which aren't really all that well addressed by programs in computer science or informatics. First is computing for discovery. If you're going to be a scientist today, you're likely going to become a computational scientist. Where are those folks learning about computing? Where do they learn the computational skills that they need? Totally apart from what computer science is teaching people about how to be a software developer or how to be a data scientist. LSA cares a lot about computing for expression. That computing has changed the way that humans communicate, and the way that liberal arts and sciences people have always studied in the humanities how humans communicate with one another. Computing influences that as well. And finally is this issue of critical computing, which has already been talked about both by Tiffany and Betsy, that we care about understanding how computing is influencing our world, and more people should be informed about that. So these are three themes that are present in LSA that they want to see in their classes, that computer science and information, at least at the undergraduate level, doesn't offer an awful lot. So some of the things we learned about our own program is that only about half of the students in LSA ever take any computing at all, and mostly in the framing of statistics or computer science classes. Only 20% of the students ever go on even to a second class. When we categorize the courses that exist in liberal arts and sciences, most of them are about discovery or about computational science and the natural or social sciences. And the computing intensive courses that we would associate with the expression and justice themes, those are mostly elective. So there's not a whole lot that is being put forth in front of students. When we interviewed faculty, they tell us that they want a liberal arts and sciences perspective on computing education, that they recognize that a perspective that's grounded in humanities and expression and justice and arts and in critical perspectives and justice discovery, that's going to be different than what computer scientists would have put together. And we haven't found anybody who's really trying to do this yet, to build computing across liberal arts and sciences. So we started building this program in computing for the arts and sciences. We have 3 goals. We want to figure out what does it mean to meet the needs of all liberal arts and sciences students about computing, and especially to give them the capacity to do programming, because it is a gatekeeping activity, and it's really critical to the way our society works. We want to build new courses, and then we're trying to eventually build new programs and credentials. So we have 2 courses that we created so far. I'm so excited about our course code. When it came to, well, what do you put before these things? We've been given Comp 4, Computing 4. That's what we do. We do Computing for the rest of LSA. So we built these 2 classes, Computing's Impact on Justice, from text to the web, and Computing for Creative Expression. In the fall, we're going to be building out more of our discovery-oriented classes, and then a new class aimed at the humanities, but coming from a historical perspective for the transistor on up. So if you're building a brand new program and brand new classes that haven't been offered in these areas of expression and justice, what should be in these classes? It's not like you can go to the IEEE ACM computing curriculum and say, oh, well, these are the things that we ought to be teaching. So I formed advisory groups of faculty who self-identified as being about computing for expression or computing for justice. And I gave them whiteboards where I'd already populated it with some of the learning objectives that had come out of the task force report or some of the student activities that we were thinking about doing. And I asked them as a group, please move to the right, the things that you think are important, and move to the left of things that you think are less or unimportant. So here's one of the whiteboards. This is one of those from the sessions on learning goals for a computing and justice course. I know that's an awful lot of information. Let me zoom in. This is the upper right-hand corner, the things which the justice folk thought were most important. I really wouldn't have guessed these. These really came out from the discussion. We also have all of these wonderful transcriptions of their design rationale for why these are the most important things. I want to point this out to the computer scientists. Here's where they put the things like writing secure, safe, and robust code. Those things are associated as computer science and isn't what they see as critical for computing for justice. Here's the learning goals for expression. I won't go into this in much detail, but I will point out over here, secure, safe, and robust code again. The things that we most associate with being the goals of computer science are not what these folks want for their students. It's not what they want to be associated with studies in liberal arts and sciences. So one of the things that all of my advisors tell me was, please don't frighten them off. Don't scare them off with computing, but introduce them to programming. So we've been developing this scaffolded approach for introducing computing in context. So we start out using these things we call teaspoon languages, task-specific programming languages. So here's one of them, pixel equations. It's one we use in the expression course, where students take a picture and then specify a Boolean expression for what pixels they want to modify, and then some mathematical expressions for how they want to change the red, green, and blue of those pixels. This is about building image filters. That's all this thing can do, is build image filters. And if you know anything about programming, you recognize that's a real Boolean expression, and those are really the right-hand side of an equation. But it's no for loops, no assignments, no semicolons. It's just the very bare bones part. So this is a tool that we call, it's for sentence recognition and generation, used in the justice class, where as you might guess from Tiffany's comments, you might imagine humanities people were thinking a lot about chatbots. They wanted students to think about chatbots in the justice course. So we were building tools so that students can specify a sentence model and then either recognize sentences, recognize the parts from that sentences, or generate random sentence. And while this is incredibly simple, it's really a one-liner, right? The only words in the sentence are noun, verb, adverb, verb, or article. It still is enough that you can get into bugs, that things happen that you don't expect. So we move from there into Snap, which I know that Tiffany uses a lot in her work. Snap is a really wonderful block-based programming language developed at University of California, Berkeley. And we can have students build image filters here with a notional machine, a conceptual model, which maps closely to pixel equations. We can have students build Twitter bots that have political perspectives, and we can do some data science-y kinds of things like analyzing the passenger names that were on the Titanic. At the end of the units in both the expression and justice class, we have these ebooks where we say to students, here's a piece of snap code that you've already seen. Here's a piece of Python code or processing code or SQL code that does the same thing. You answer these multiple choice questions about the textual code. The idea is that we're not going to be teaching Python, SQL, R in this class, but we want students to see what the mapping is. We want them to see that what they're doing really is authentic in the mainstream sense, but I'm not going to teach those things, at least not in this first class. So some of the open research questions we're exploring. Are these working? Are arts and humanities students and faculty getting what they need from thes classes? What is the students follow when we do this multiple language stuff? I want to show you one picture of something that I thought was really amazing. The students are working on image filters in Snap. And they're all building the various image filters. They've done the pixel equation stuff. And I look over at one table and I see this. The kid in the middle is doing pixel equations again. He's moved back to the teaspoon language. I asked him why. He said, well, I found it easier to think about. And then later on, he moved his stuff into Snap. They're doing the transfer. They're handling the multiple languages. So let me tell you some of the research questions we're not exploring. I'm not exploring whether or not these students go on to major in computer science or information. I'm not asking how difficult it is for these students to learn C++ or they end up in the computing industry. I'm certainly not asking whether or not they learn how to write safe, secure, and robust code. Instead, our focus is on what is authentic and legitimate within the liberal arts and sciences, and how can we support that? Thank you very much.
Right, fantastic. Thank you so much, Mark, for that wonderful talk. And yeah, we have so much to think about, I think, from these three talks. So I'd love to ask all three speakers to turn on their videos, and we'll have a little bit of a panel discussion. And I wanted to start us off with a question that I think kind of came up as a theme throughout these three talks, which really interwove with each other really nicely, which is around what we define as computing education, maybe how that relates to computer science education. We saw a lot of different kind of perspectives on what we think we should include in this, from data work, artificial intelligence kind of changing some of what we're doing, and Mark talking about liberal arts education and how that intersects with computing. And so I'd love to hear your perspectives on what you think counts, and also maybe what are some of the challenges in us shifting our perspective and definitions of what computing education is, particularly for these really entrenched programs that have a very specific kind of definition of computer science education.
Sure. I mean, one of the things that I think is most interesting about this is that if you really look at the history of computing and the culture that emerged out of computing initially with this sort of hacker ethos, most of those people weren't trained formally in computer science because it just simply didn't exist as a discipline per se. And so it's amazing how quickly we've gone to this very formalized notion of what it means to be a computer programmer, right? That you have to go through these formal sort of classroom environments, or be part of a community of practice where you're taught the things like, oh, you have to prepare for a technical interview, or this is how we talk about this sort of thing or the other sort of thing, and the vernaculars that are used within the field. So I think it's sort of interesting that the field's moved so far over to this sort of certification in order to be considered someone who's doing computing.
I think Mark's slides already answered some of what we ought to be moving towards in terms of thinking about what we need to teach people about computing. I think that what we're really behind in is that people haven't really done a lot of HCI around how we really should be having people like actually interact with and get computers to do what they want, right? I think that's actually a major reason why we've gotten this idea that like computer programming is this sort of thing you learn and you've got to hack it and figure it out, is because we haven't bothered to make the best, to do the best research on how we can help. And I think Mark is actually part of that, is like, actually, how do we help people just do the stuff they actually want to do, instead of, let me give you some baby tasks in these stupid languages that we made that have these abstractions that are useful for the machines, but not necessarily for people. And I think we did have a great history of, at first, like, make these devices that do some logic stuff and let them do some math. And that would be great because we need to solve some math and some physics equations. And then let's build some layers on top of that so we can do some more complex stuff. And we've done that to an extent, but I think, computing has grown so fast. And then, like I said, now we're at AI that the HCI can't keep up. And so I think we almost need to jump over and say, let's just, like I said, I actually think, Mark and Betsy and many people are doing some work like this, but jump over and see, what do people need to do, right? And help them do it, and help them do it in ways that they already can express. But that doesn't mean there aren't any things that are sort of not uniquely computing, right? Like the idea of an abstraction and the idea of, now I'm going to make a new tool that can do this thing, and every time I do it, it's going to do the same way. That's a very computing centric idea, right? And the fact that it can be made with software means that we can make it without having to get materials. And that, to me, even when I started doing computing, was the thing that got me inspired. It's like, I don't have to buy some stuff, so I can do this, right? I have a device, and whatever I can think of, I can do it. And I think that's where a lot of us got our imagination, is like, hello world. It wasn't so much that like we could type stuff, it was that we could get the machine to do what we wanted it to do. And now we can do that to some extent. And if you think about, like, I don't like the term end user, but like, we think about, people need to interact with machines to get stuff done, right? And it's really unfortunate that, like, the most that people interact with machines, like probably the most frequent thing is like, let's all use Google. And then there's been turned into, now Google and other places use all this sort of interaction we do so that they can sell stuff to us. But can we figure out how we can use these interactions, or get interactions going where people are actually talking about solving important problems? Like, where's the Google for that? So I see computing education as like broad, and it's like, how do we make abstractions to get stuff done to solve problems?
So I want to frame what I'm doing back in the space that Tiffany and Betsy are talking about. I've been part of the broadening participation in computing community for a long time. I really care about that a lot. But what I'm doing now is, rather than trying to bring more diverse students into computing, I'm trying to go to where there's greater diversity. The liberal arts and sciences are much more diverse than engineering and computing programs. And I'm trying to bring computing to them. And it's about broadening participation in computing, but computing as a field, as in terms of the ability to do programming and computer science and AI, as opposed to making them part of computer science. And yeah, as Tiffany said better than I did, I see myself with these teaspoon languages saying, why did we evolve languages the way that we did? Why can't we go back over again and say, what is the people are really trying to do? And let's build programming, give them the ability of programming for their tasks. So yeah, I strongly agree with what Betsy and Tiffany are saying. We originally in computer science didn't get so hard classified around this idea of computer science. We used to be about all kinds of different things, making it broadly accessible. We need to get back to that.
Fantastic. And maybe I'll jump us over to a related question that I think we've been touching on a little bit, but I want to tease out more explicitly, is, as we're broadening this definition of computing, incorporating it into different kind of areas and fields, and thinking about different goals for which people might want to engage with computing, I think this brings up a question of what skills might people need to have, and also what languages would we want to teach. So we had a conversation before this dialogue about why are we teaching Python? Is Python the right language to be learning? And I think we've been hearing about the value of being an expert in Excel, the value of block-based languages like snap, and maybe even kind of rethinking languages entirely to create some, as Mark, you were talking about, these kind of more teaspoon languages, and Tiffany, you were bringing up these kind of interfaces that allow us to do what we want. So where do we think, how do we think about what we think we should be teaching, and particularly from a languages and maybe tools perspective? How are you all thinking about that?
Well, I think we ought to be thinking about what people want to do again. And like I said, I definitely think Mark is moving in that direction. But I think, lots of people have done good thinking about this. Like computational thinking was sort of one of the ways to say, like, computer science isn't what, whatever we're saying computer science isn't now isn't what everybody needs to do. Computational thinking is like learning about abstractions, learning about algorithms, learning about problem decomposition, super important now, and debugging. Because as I said, I think the future is like, we're all going to have to do our jobs with AI, right? We already right now have to wrangle with, like, any job you do, you've got to wrangle with whatever computer interface they give you to do, to do the job, right? Like as a professor, I sometimes have to use Moodle. I cannot stand it, right? I would really like to say, change this whole interface and like, just make my grade book and do this thing right here. I want to verbally do it. And then I want to say, okay, present to me what you made, computer, and then go, no, that's not right. Let me change that. That's what I really think we need to do. We need to interact. We need to get computers to make things for us, like prototype stuff for us, and be able to like give feedback to it and be like, no, that's not what I want. That's kind of where prompt engineering is now for ChatGPT, right? So people are learning, like, how do I get ChatGPT to do the thing I want it to do? But you really have to have great critical thinking skills. You've got to have, in order to use it to do real stuff, you've got to have great problem decomposition. You've got to be able to look at what it generates for you and decide if it actually is what you want it. And then you've got to figure out, okay, how do I get this machine to modify it the way I want? That's what I think we need to be teaching people, is the critical thinking, abstraction, algorithms, also like iterative processes of designing and making things and refining them. That's where that's what I think everybody needs, because we're going to need to do it for work. We're going to need to do it for our stuff. That's what I wish we had better interfaces to do it, but I think we need to teach those things.
Can I jump in? So one of the things that I learned from Betsy that I'm trying to do in PCAS is to recognize that we can't answer your question now, what is it that people need to learn in computer science, from our perspective as computer scientists. Well, I spend a lot of my time now talking to people across liberal arts and sciences all the time, asking them, what do you do in computing? What would you want your students to know about computing? And I've discovered, there are these computing cultures within these different communities. Like I was just talking to somebody from biophysics today, and he's like, I don't actually know Python. Mathematica is the way to go. And they have, all of this culture around Mathematica. And I was just talking to somebody in anthropology of all places, who's been having kids do music compositions with R. And I'm realizing that there's all of this stuff that we computer scientists, I don't know how many computer scientists would say, yeah, R, that's the way to build music. These other places are building computing cultures, and we have to go investigate those cultures if we want to support them, because we're not going to figure it out on our own.
I have a super practical answer. I mean, this is just from the context of DataWorks, is that we find that once the data workers have a certain amount of expertise with Excel, we're able to introduce Python pretty easily, right? And we have built out our curriculum around teaching them some Python based off of what they're doing in bioinformatics, not what they're doing in computer science. Because in computer science, they're teaching a level of abstraction that the data workers actually don't need to get the work done that they need to do, right? And they don't have a motivation to learn that level of abstraction right now. They may one day, but that's not the goal. So it's it fits in with both, I think, what Tiffany was saying and what Mark is saying, right? That like we're meeting them with what they actually want rather than this higher idea of what it means to be a computer scientist. I should only say computer scientist with big quote marks from now on. So.
But we shouldn't say higher, right? It's not that it's higher, it's just that it's different. right?
Yeah,
Computer
yeah.
scientists, they go use those abstractions, and everybody else is like, well, we're using this one and this one and this one and this one.
I just want to say I love the word culture that's getting used here, because when you learn how to do something, you want to be in a part of a community of practice that knows how to do that, and also knows how to do stuff that you don't know how to do, right? So you can find out from other people. So I think one of the central things is like, thinking of computer science as only being about the computer. And I think that's why we, HCI is behind in terms of using it. It's not about the computer. We always have made these things to solve problems, and we need other people to solve important problems and hard problems. If we just want to do little baby problems, yeah, we can interact just with a computer, but we need to be able to not just get a computer to do stuff, but also how can we think about doing computing with other people, like make stuff with other people too. So I haven't mentioned that before, but that's another thing on my mind these days is, I think we need to collaborate between humans and machines, but humans and humans, and how can machines help with that too. But people help each other, right? Learn stuff, do stuff, and the abstractions, right? Like getting from my high level of people need to learn abstractions. It's like, well, the practicality is my data's in Excel. I want to transform all of it, and it's such a pain to do it this way, or I do a process, and I'd love for that process to be automated, and I don't have to do it again, or I can. And I mean, way back when, I think many of us have tried different things to try to get people, interested in learning computer science. I did a lot with games, and, but it really is a pain. Like when you try to make a game, you're like, you do all this work, you make a model, you make the animations, you program what you want it to do, you specify all the interactions, and then you're like, wow, I figured this out. And then you're like, I want another one of these, but I want it green. And then, but you have to do all the same work. Like, why? You shouldn't have to do that.
Well, I want to take us to talk a little bit about so I think we've been talking a lot about expanding pathways, expanding how we define computing, fostering more interactions between people, between computers. And of course, one kind of practical reality is like what this looks like in terms of the careers and work that people end up doing with these skills as they're developing them. And I know, Betsy, at the beginning, you talked a lot about kind of gatekeeping around computing careers. And I think also thinking about, well, as folks are developing different sorts of skills within different disciplines, what does it look like to kind of enter the workforce, and how can we kind of maybe broaden our understanding of what it is to do computing work from a workforce perspective. So I'd love to hear your thoughts on that.
Yeah, I think it's kind of a twofold problem. One is that there is a lot of gatekeeping that happens in computing, right? Where it's that you have to fit a certain sort of educational background in order to be accepted in those fields for the high paying jobs. And I guess if that's the hire that actually matters, Mark, it's the money, right? And the job security. But then there's another side of it, is that we know that women and underrepresented minorities underestimate their abilities. So if they see a job that has 10 requirements, they won't even apply for the job unless they know they have all 10 of those skills, versus we know that particularly white men are much more likely to apply for that job even if they only have 3 of those skills, right? And so it becomes sort of this double whammy where we're keeping out underrepresented minorities, both by their own cultural sort of background, and also because of the fact that there is this culture of computing that is gatekeeping. I'm not saying I have an answer here, but I think one of the things that the student Laura that I was talking about brought in is that she's actually pushed her way through the field, not having formal CS education, to end up in a software engineering role. And so she understands the networking and work that has to be done to learn those cultural norms so that people can be accepted in computing. I think the next piece is to actually change the culture of computing. I don't know how to do that, right? There's a lot of things that we need to change about the culture of computing, that even people who get in who are underrepresented or minorities or females don't stay because the culture of computing is so unappealing to them, or openly hostile towards them.
Yeah, and I didn't make the connection, and I apologize that I didn't when I was giving my presentation. The reason why I brought up STARS in the first place is that we really worked hard to change the culture within the departments that we worked in, and we established conferences where students got to meet each other. And so the culture that we tried to establish within STARS was to empower faculty to get students together in groups to work together to solve the problem of writing participation in computing. But we didn't just have them do things to improve CS education. We said also STARS students, like students in computing departments, could do research as a thing that was a way to broaden participation in computing, because if they were diverse and they wanted to do some research, that they would be bringing a different perspective into computing that wouldn't have been there otherwise. And so really, that's really why I brought up STARS, is that the whole idea is if we can get new ideas in and support students in making and doing things that are important, then we're going to be moving in the direction of having a better culture. And what our research showed over the course of STARS was that students who were in STARS, they were diverse, they were more reflective of the US population, and they helped each other learn this culture of how to get into the jobs, and they learned about careers and how to get into them with each other. So if we can connect more students to each other and to more faculty, then we can have people see more people like themselves, you know, across universities, because any one university doesn't have the right diversity to show different things. But if you connect with historically Black colleges and universities, and you connect with Hispanic serving institutions, and the students can meet each other across at the, like STARS has events like STARS Celebration is coming up September 16th in connection with the TAPIA celebration, which I totally suggest that people send students and faculty to. And we also have the Respect Conference on broad participation in computing research.
I mean, one thing, Tiffany, I noticed from the STARS students that I've met, particularly those who come from, you know, sort of typically represented groups in computing, is that the ones like the white males that I met that were part of STARS were actually way more aware of kind of the cultural issues, and we're already establishing that cultural norm that I wanted. I mean, I think the program was so successful in that way. So.
And I think another thing that you've done with Respect, Tiffany, is help to address the question that Miranda Carter put into the Q&A. So how do we actually change the computer science departments? I mean, STARS is doing that, but also with the Respect Conference, you've created a way for people to do BPC work and get that academic cred. Here's my pub. Here's the thing that I did that is worth something. It's the coin of the realm in the academic community, and you can get that through Respect. So I think that's one of those small levers that we can pull to eventually try to change the field.
Wonderful. Well, I'm noticing that we're just about out of time. I think this is a nice kind of uplifting note to end on of some ideas for where we could go from here in terms of shifting the culture of computing. I know we could talk for a lot longer, but I want to wrap up by thanking all of our fantastic speakers for this really engaging dialogue. I have lots to think about kind of coming out of this. So thank you all for participating, and thank you for the audience, for everyone attending today's Thought Leader Dialogue. I just want to remind folks that if you've enjoyed this event, Northwestern Center for Human-Computer Interaction and Design has a website, hci.northwestern.edu, that has information about other events. The recording from this event will also be posted online in a couple of days if you'd like to go back to anything. I think this is our final event for the spring quarter, so thanks everyone for participating in the HCI+D events this year, and we look forward to seeing folks back in the fall.